Story so far. We have moved on from right angle trig, but it still sits there just in case we need it, because it might come into play in various questions that we mess around with. We know that the angles of a triangle are just referred to as capital A, capital B, capital C. The opposite lengths of angle A is little a, opposite B, little b, and opposite C, little c. We have happily played with the area formula. Do we agree? A half AB sine C. And the big takeaway from this one is obviously if the question says, please find the area, or if you are given the area, then we're looking at this formula. We're writing it down. We're subbing in as much information as we possibly can. What's the other thing that we should think about when we're using this formula? What information sort of do we need? They're very silent. So it's about the two lengths and the angle has to be in the middle. Remember that? Do we? So if I said, find the area of this triangle, 15, 24, and 38, you would tell me, sorry, no, cannot do. Because what we need is we need this angle here to have that done. All good? All right. Did we look at the sine rule or not? No. Okay. So today we're going to look at a thing called the sine rule, but before we do that, do we have some questions from the area of the triangle? Area formula to do this one now. Okay, so everybody paying attention, tuning in, and we are writing our rule. So one of the rules we're looking at is the sine rule. And our sine rule is A over sine A equals B over sine B. And if I really wanted to, I could finish that off and go equals C over sine C, but I don't need 3 ratios if you so desire. I just need the 2. All right? Or we could have... yes, we'll go pink. I could have sine A over A equals sine B over B. What is the difference between these two? Anything? Or if I gave you $10 to say what's one thing that's different, what is it? Yeah, they just switched. So here we've got the length upstairs, and lo and behold, this is the one you will use if we're finding an unknown length. And here, what's upstairs is the angle. And so this is the one that you will use if we're finding an angle. And hopefully you'll see, as soon as we do a question, it'll be, oh, okay, yep, I get that. Now with our area formula, it was all about the two lengths and the angle in the middle. Okay, with the sine rule, it is all about pairs. As you can see, A on sine A. So A, sine A. B, and its opposite. So we need pairs, a known pair, at least. So remember, you're going to have 3 different formulas really to play with. You're going to have the area formula that we've already covered. We've got our sine rule. Then we're going to have our cosine rule. So there's no area to be asked about. So we're ditching that one. And we're looking at this question. And the first thing we see is that I've got an angle and I've got its opposite length. And I want to find this x. And lo and behold, I do indeed have its opposite angle. So straight away, paired up. That means I'm going the sine rule. I'm going to be a little bit sloppy, I guess, because I'm going straight into it. I'm not even going to write A over sine A, B over sine B. I'm just going, this is going to be 18. Oh, actually, I lie. Start with your unknown. So it's going to be x all over sine of its opposite angle. So everybody happy that this is just going to be over sine 113? And it's going to equal, right? Length's upstairs. What's it going to equal? Yeah, 18 over sine. And you're sort of a little bit suspicious because you go, seriously, it can't be that easy. Yep. Pretty much done. Yep, you just have to finish off. I don't want x divided by sine 113. I just want x, so how do I get rid of the divide by sine 113? Times. Done. I'm not kidding you, it's that simple. So off to the calculator we go. Pump it in. And our job is done. Okay, we're going to pop that in, go into normal calculator mode. I'm in degrees, so 18 over sine 41 times sine 113. I remembered. It's an exciting moment. Thank you. They're clapping, but it is a big deal these days because the memory is starting to go. So 25 point, if I'm going 2 decimals, 25.26 meters. That's it. So if we have a look, question 1, yep, away you go. We've got pairs happening, all is well, all is good. So do you need to do all 3 questions from question 1? I don't need you to, you can pick any 2. Please pay attention. Okay, if we look at question 2, you sort of go, oh my God, is this the same thing? Uh-oh. Here's my length, here's my opposite angle. Here's the length that I want. I don't have its opposite angle. Does this mean you tell me I can't do this question? No, you can do this question because you should be able to find what this angle is.
Yeah, because 180.
Yep, exactly. Say that loud and proud.
Because a triangle equals 180.
Right, there are 180 degrees in a triangle. So you've got 2 of the other angles, which means you should find this one. Oui? So don't do what I've just said and say, don't do it, you can't do it. But if you've got the other. So again, same thing here, 180 degrees in a triangle. Bless you, we can do this. Happy? So, not a lot. 1, 2, 3. I'm going to interrupt you in 10 minutes to look at using the formula to find an angle shortly. Just as nice. Carry on. Okay, so we want to find x, but alas, I don't have its opposite angle. However, we do have the other 2 angles here. So to get this angle, do we agree it's going to be 180 minus 83 minus 39? Okay, so that means we have got x over sine 58 equals, and now we need the known pair. So have we got a length and its opposite angle, one other pair? Yep, we've got 7 and 39. So it'll be 7 over sine 39. Right, just make sure that you're signing the angle. Make sure that that's downstairs when we're finding the length. And lo and behold, to get rid of our divide by, we have to times. Question 3. It's just asking you to find an extra length. So pretty same as question 2. You can find your angles same way, 180 degrees in a triangle. X, it's got its pair. And once you've found this angle, then Y has got a pair, and use your known, use 71, 115 over sine 71 as your known pair, yeah? Can I just ask you to all look at C? Yep, CC. What's our problem there? We've got a known pair, length and opposite angle, so that's good. X, and we need its angle. But we haven't been given this one. So have we got enough information for C? Rowan's going yes. Grace and Adele were saying yes. So how? No Pythagoras. There's no right angle there. So how can we know what these 2 angles are? It's got to do with this information here. It is an isosceles triangle. And what do we know about an isosceles triangle? The sides are equal, but what else? Right. This angle, right? This angle and this angle must be the same. Okay, so because we still know we still know, it always is, that there's 180 degrees in a triangle. So that means it's going to be 180, take my 102, and then we're going to split it between the two ones that we have. Excellent. So we get 39. So that's 39 degrees, so is this one, and I think then you have enough information, okay? So a little bit of geometry skills come into it. Use the sine rule to find an unknown length. And keep in mind, we're talking about pairs, okay? But clearly, it can be the situation where we could use the sine rule to find an unknown angle. And it's pretty much the same thing. There's just one extra bit that we have to take care of. So again, this is in your textbook. The examples are there. I will cut and paste and I'll leave it on the board, but I'd really like it if you just listened and then we'll follow up. So we've got the diagrams. We want to find our answers to one decimal place. So once again, if we're looking here, we've got a known pair. But this time I want to find an angle, and luckily I have its opposite length. Now, to save us a little bit of hassle, what we're going to do is, instead of having A over sine A, because our angle is unknown, I'm going to start with sine of the unknown over 6. It just makes my life and your life easier if we have our unknown upstairs. If I didn't, if we did exactly what we did last time, well then we'd have 6 over sine theta equals 8 over sine 63, and then we either flip both of them to get back to this, or you have to do a bit more algebra and go, okay, how do I get rid of divide sine theta? You've got to times and blah, 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 blah. So it just makes your life easier if you always have the unknown upstairs. So here we go. I want to get theta by itself. So first we're going to get rid of the divide by 6, and you all go times by 6. So we get sine theta equals sine 63 over 8 times 6. And goodness gracious me, I think we know what to do now, don't we? To get rid of the sine, what's it called? Inverse. Again, some of you might be waiting. Surely it's not that simple. Where's the trick? No trick yet. Now, I am going to put something at the end of this. So if you, I did say don't worry about copying it, but I know some of you want to. So if you were copying it, just leave a bit of a gap. So to check that I'm all good, remember, sine 63 over 8 times 6. I want to inverse sine this. Now, I know, Gussie, I know that I'm sort of on the right track, because when I now want to do sine to the minus 1, take the inverse of this, because it's less than 1, but bigger than minus 1, I know that it's all good. Because now look, so shift sine of my answer, that will be the angle. If I tried to do shift sine of 1.125, look what happens. Error. Okay, and we'll talk about that a little bit later when we look at the graphs of sine and cosine as to why that is. But that's why I don't just like to type everything in, sine, theta, bracket, but I like to actually do what's in the bracket before I sine to the minus 1 or cos to the minus 1, because I can pick out if I've done something wrong, written the wrong number, put something dodgy in my calculator. Okay, so 41.9. Okie dokesters. And then we do exactly the same thing for the other one. Okay, we've got pair, we've got a pair. So once again, sine theta over 17 equals, and I'll stop the video because I think you know what's coming. This is important. So when we are finding an angle with the sine, we have to consider what is called the ambiguous case. Great word. ambiguous. The ambiguous case. Now, does anyone know what ambiguous means? Big. No, it's not big. Oh, I love that expression. Say that again.
Shrouded in mystery.
Excellent. Ambiguous. Unclear, possibly. And in this case, what it means is that we could have two solutions for the triangle with the information that we've been given. Okay? So we have to check, is there one solution or are there possibly two solutions? Are we checking? Now, why is it so? Well, I'm glad you asked. So if we look at this triangle here, right? What are the things that are dead given? By the way, look at this answer that I've got. 56.1 degrees. Does that look like it's 56.1 degrees? Doesn't. And it doesn't mean that it's wrong because diagrams do not have to be drawn to scale. But what I want you to consider is that I could have these same values but have a different looking triangle. Because imagine if instead of this 8 coming in like so, what if we flicked it out? So this 8, what if instead of going here, we just flicked it? We flicked it out to be 8 there. Can you see I get a different triangle? But I've still got a length of 8. I've still got this length of 17. I've still got this length of 23. And this would be my angle of 56.1. Does everyone see that? But what about this angle then? How do I find that? Well, I'm glad you asked. This is what we have to do to check for the ambiguous case. It's highly technical. Not. So here we go. Check for ambiguous. So the angle that we have just discovered, we go, what's 180? Take that angle. I know, I should do that in my head, hey. 123.9. And we then look at this angle plus the angle that we've got in the triangle. So do you know what I'm about to say? Because don't talk while I am, please. So we take that 123.9 and we add it with the angle that's already in the triangle, which was the 23. Now, is that answer going to be less than 180? Yes. So therefore, ambiguous case rides. So that means we could have the angle of 56.1 or 123.9. So think about this. All you have to do, the angle that you find, you go 180, take that angle, because you're saying this could be the other possible solution. But then you add it to the angle that's already in your triangle. If it's less than 180, we go, huzzah, we've got two solutions. If it's more than 180, we will go, impossible, can't happen. So let's see what happens with this one. Let's check. So 180, take 41.9, gives me 138.2. I hope. We go 138.2. So we're saying, is this a possible solution? 138.2 plus, what's the other angle that was in our triangle? 63. What did you just say? You said it's... So what's 130 plus 60? Well over 180 degrees, so it is not possible. That's my only solution.